These are called force meters. This shows the number of newtons that are needed to move an object. You've seen these before, right? No. Never used these in science before? No. Oh, we need to learn about it. Okay, so these are force meters, and I'll put them on your desk a little bit later. You pull, and then it shows you how much force is needed to move an object, okay? Now, example exercise 1. If the force of friction is 16 newtons, right? That's how much friction is acting, how much force friction has on this box. What do I need? How much force do I need to give to move the object? If we said we need enough force to overcome friction. Go ahead, Brianna. Complete sentence. Everyone tracks. This is a big deal. Track.
The amount of force needed to move the object is higher than 16 newtons.
I love that you said that. Higher than 16 newtons. So 16.1 would move the box just a little bit. 16.5 would move the box just a little bit. Would 15 newtons move the box? Yell it out.
No.
Nope. Okay. So you have that. 16 newtons. Anything higher than 16 newtons, you can use the greater than sign. It's right under the calculate on your sheet. Okay. Now, go to the right, and right, and right. Okay, so the answer is anything more than 16 newtons.
Where?
On the sheet where it says calculate. Come on. Okay, we got this. Go to the right again. Using rolling friction. So now we find this this little picture. And we're filling in the box to the right of this. Here we go. First bullet. Let's go, Tobias. Come on, you can do it. Go ahead, Danielle.
Reducing friction makes it easier to move around.
Great. Reducing means lessening friction. One way. Go ahead, Kaylee.
One way to reduce friction is to change stationary friction to rolling friction.
Okay, let's think about this. Don't fill it in yet. Tracking me. I know it says a little something different. It's okay on your notes. Okay, hold on. So this is static. Let's say this is a 200-pound box and we cannot push it. Putting wheels on it will turn static friction into rolling friction. And we know that static friction it's way harder to overcome static friction than rolling friction. So like that computer card out there, if it didn't have wheels on it, can you imagine, like if I asked Annabella, like, come on, pull it in, without wheels on it, it'd be hard. You could do it because you're strong, but it would be hard. Okay? She doesn't care. Okay. Putting wheels on it reduces the amount of friction that there is. Okay. Now, last one, rolling friction. Yaneli, good job.
Rolling friction almost always ends up being less than stationary friction.
Good. Okay. Going to the right now. Go to the right, come on. Okay, you can also reduce friction by using lubricants. What I mean by this is, have you ever baked a cake? Or watched someone that baked a cake? Okay, well when they bake a cake, you put oil on the inside of the pan. That's so that the cake can come out of the pan easier and it doesn't get like stuck inside the pan. Okay? So, lubricants are materials that reduce friction. Fill it out quickly. Can someone read the for example? For example. Go ahead, Martha.
For example, in a car's engine, metal parts in contact with each other have a lot of friction. Oil is used to reduce the friction between metal parts.
Yep, this goes on to the next page. So let's think about this. In a car, people use oil so that it reduces the amount of friction. We get it. Okay. Have you ever had a creaky door hinge and people were like, you better put some oil on that or something? That kind of stuff. That's like a lame example, but there are zillions of examples of people using oils and stuff to reduce the amount of friction. These are all examples of different lubricants used to reduce the amount of friction. Write it. Yes. Yes. Read it. Example. Okay. Great. Hannah has a good example. Hannah, please share your example.
When you have a ring and then it's stuck on your hand, and then you put oil on your hand so the ring can get off.
Yep, or lotion or anything like that. Okay. Sometimes, like when it gets hot out, your fingers actually swell, so people have problems with that. Did you know that?
No.
It's because of the heat that your hands retain water and they get like fatter. Yeah. In the summer, your hands are fatter than in the winter.
My hand really got fat.
Charles is perfect. Go to the right. Okay, here we go. So, not enough friction. Moving on. I have a loud reader read that. Have you ever? Go ahead. Luna.
Have you ever slipped on an icy sidewalk or seen a car skid out of control? These things happen when there is not enough friction between surfaces such as your feet and the ice or the tires and the road.
That's good. Thank you. Great job, fill in the blank. So this is kind of a crazy idea. There are a lot of times where people put friction. What about when it's icy on a path going up to your house? What do people do? Go ahead, Lex.
They put salt on it.
Salt on it. Why do they put salt on it? Go ahead, Jose.
You won't fall down.
So you don't fall down. What does it do? The salt. What does it increase? Go ahead, Brianna.
Because it makes it rougher, so it's harder. Because
It increases.
it increases the.
Yep. Perfect. Okay. All right. So there are times, and read the examples, please. Let's go, Elijah. Read the examples. There are times.
There are times when we need to increase friction between two surfaces.
And examples. Examples. Read it.
Basketball shoes.
Keep going.
Track shoes.
Read the rest of the examples.
Track shoes.
And you don't need to write it in between. Waste time.
Rubber.
Oh, rubber.
Rubber mat on the stairs. Okay. That was weird. Okay. So now what we're going to do is you have a little guy to practice. Turn your papers over to the next page. Go to the right. Okay. You will have 2 minutes to talk with your partners to answer these questions. We're going to go over it. Super quick, 2 minutes. If you don't have a partner, find someone near you.
Do I turn this off?
Yep.
By the way,